In this video, I will show you how to fill out the non-folding foldable for writing and solving equations from word problems. So to do this, you're going to need the larger square that you got in class today, and you also need to have this slip that has the 4 word problems on them. You'll need some scissors and a pencil, and then obviously tape to put them in when you're finished. So the first thing that you're going to need to do is cut these apart so that you have the 4 word problems separate from each other. And then look for the one that says Robin has some video games, because that's what we're going to use to fill in this foldable, and then the rest are going to be used later as examples. So I'm going to set those off to the side and stick with the Robin has some video games. So remember that along the way, if you need to pause the video to keep up with writing what you need to do, just pause it and then come back to the video to play it for the rest of the tutorial. So, like I said in class today, the hardest thing about algebra for a lot of students is writing good equations from word problems. And one of the things that helps students sometimes figure out what kind of operation they need to use with a word problem is to not have the numbers involved. And so that's why I don't have numbers here for how many more games Robin had or the total of games. So first we're just going to think about it without the numbers there. Robin had some video games and then bought some more games. We don't know how many yet. I'm going to tell you in a few minutes. If she now has a total of blank games, how many did she start out with? So a lot of times what students want to do is to write an equation where they have a variable on one side of the equation and then a bunch of numbers on the other. But we're going to think about this more as a situational approach, step by step through the process. So first, we're going to do this part of the foldable, which is defining the variable. That does not mean that you're going to tell me what variable means. In this case, it means you're going to pick a letter that you're using as a variable and then tell me what that variable means in terms of the problem. So here what we're trying to find out is how many did she start out with, and we're talking about games. So how many games did she start out with? Some people like to use x for all of their equations. Some people like to use a variable that relates to the particular word problem. So I'm going to go with g for games. And I can't just say that g equals games because we have different situations with the games here. She had some video games, so she started with some. Then she bought some more games, so there's a different amount of games. And then she has a total of some number of games. So we need to be more specific here than just games. We're specifically looking for how many games did she start out with. You don't have to put exactly what I have here, but something that means the same thing as how many Robins had before she bought more. So now we're going to go over to the equation part, and obviously we're going to use g to represent the number of games she had to start with. So rather than creating an equation with g equals something, let's think through the situation. She had some video games, and that's what g represents. She had some games, we don't know how many. And then she bought some more games. I'd like for you to fill that in with the number 5. So she bought 5 more games. So if she had some games and then she added 5 to her collection, now she has a total of, fill in the number 12 here. Now she has, 12 games. Now we have our equation. And I know that you already know how many games she started out with based on the numbers that we have here, but you still are going to have to go through the process for solving. So we have the equation g plus 5 equals 12. We're going to subtract 5 on both sides. and we've determined that the number of games she started with was 7. I still need to do my check. Remember, these are going to get harder as we go along. So just bear with me on the check. We're checking to see if G plus 5 equals 12. And G is 7, so we're checking to see if 7 plus 5 equals 12. And since 7 plus 5 is 12, yes, that checks out. And down here I have a reminder, we've already done it, but don't forget to check it. And then this last part just puts our solution, G equals 7, in sentence form. So remember, we're talking about Robin, and we wanted to know how many games she had to start out with. So Robin had 7 games to start with. You don't have to have that exact sentence, but that's the meaning that you have to put for your sentence. The reason I have you do this with a sentence is because sometimes people come up with completely unreasonable answers, and once they put it in sentence form, they realize it's not reasonable. So it's important to be able to interpret your solution into sentence form and then also run it through the is this reasonable filter as you're writing the sentence. So this is going to go on the next available right-hand page in your composition book. And you can go ahead and tape those in right now. So pause the video if you need to tape these in. And then we're going to do 2 examples on the left-hand side, and I'm going to leave out the third one for the sake of time. So the next one that we're going to do is some number of friends found money on the playground. Now, really, if you found money on the playground, I think you should turn it in, but these friends think that you should keep it, apparently, because that's what is happening here in the word problem. So you're going to put that up here, and we're going to fill in some numbers after we talk about the situation. So some friends found money on the playground, and they split the money evenly, and each person got, and I'm going to give you that money in just a few minutes, how much they got. How much money did they find on the playground? So remember that we're going to first define the variable. So you're looking over here at the foldable that you have. You have to tell me what variable you're using. I'm going to use M. And M doesn't just mean money, because we have 3 situations with money here. They found some money on the playground. Excuse me, we have 2. So they found some money on the playground, and they each got some amount of money. We're specifically looking for how much money they found on the playground. So you could just say money found. So rather than having M on one side of the equation and some numbers on the other side, we're going to specifically think about how you would figure this out along the way if this situation was happening to you. So we're going to put that there were 3 friends playing on the playground. They found money, and they each got $14. So fill those into this little slip with a word problem. And then let's think about the problem. They found some money. They divided it among themselves, so they took that money and divided it between the 3 of them, and each of them got $14. So our equation would be M divided by 3 equals 14. To solve that equation, we're going to multiply both sides by 3, and of course we end up with M equals 42. So now we're going to check, does M divided by 3 really equal 14? So 42 divided by 3, does that equal 14? And yes, 14 does equal 14. So that's correct. So now the last step, remember, is to state the solution in sentence form. So we need to go back up to the question. It's asking us how much money did they find on the playground. The friends found $42 on the playground. And last, we're going to do the text message problem. So he sent some text messages last week. On average, how many text messages did he send each day? So obviously we're talking about 7 days in a week, and we need to define our variable. What we're trying to find is how many messages did he send each day. So maybe I'm going to do a T but for text, but notice that I'm using a T with a little tail on it so it won't be confused with a plus sign. So number of texts can't be just text because we're talking about how many texts in a week and how many per day. What we're trying to find out is how many texts per day. So now we're going to write an equation. Josh sent 140 text messages last week. So write that into the word problem slip. On average, how many text messages did he send each day? Well, one way to think about this is to say that he sent 140 text messages divided by 7 would equal the number of texts that he sent. So in this case, we have a variable on one side and just numbers that we would simplify on the left side. So if we did that, then T would equal 140 divided by 7, which is 20. So there's really no doing the same thing to both sides in this situation because we already have the variable isolated, so we would just have to simplify the numbers on the left. But another way to think about this is that for every one of the 7 days of the week, he sent T number of texts, and you can multiply those values to get the total number of texts for the week. So here's another way to think about that. 7 days times the number of texts per day equals a total of 140 texts. So to solve this equation, we're going to divide by 7 on both sides. So we come up with the number of texts he sent is 140 divided by 7, which is 20. So double checking, does 7t equal 140? Well, 7 times 20, does that equal 140? Yes, 140 equals 140. So the final thing we need to do is state our solution in sentence form. Josh sent, and we're going back to our equation, the solution for our equation for this. This solution is where we find our answer that we're going to put in sentence form. Josh sent 20 texts per day. And you're done. So now you need to use that same setup for when you're doing your worksheet. So I'm looking to see that on your worksheet you have defined the variable, you've written the equation, solved the equation, and written your answer in sentence form. And just so you know, you don't have to write and rewrite the equation. That can be all in one step. I just have it separated out so you can see the steps that I want you to go through. That's it.